All right, on the bench. I have to step away a little bit from this one here. Got a big radio here. Probably the largest CB radio ever made, and probably um, one of the best looking, if not the best looking, CB radios ever made. And of course, that's my opinion, but I think the reason why people like these is more for looks and probably less about its performance and definitely less about its reliability, um, which is one of the issues that plague these DAK radios. So this is a Mark 10. So this is the sideband. You have a Mark 9, which looks just like this, except it's AM only, no sideband. So, but yeah, it really is a nice looking radio. So this is a local guy, Scott. Um, and yeah, he's got a bunch of radios. So I already fixed one of his radios, and this is the second one, and we're just going to go down the line with fixing his radios. But this one was second. And yeah, just a good radio. So this is what they call a hybrid um, radio because it is basically the driver and the final is eliminated off of the Cybernet board in here, and it's run into a vacuum tube driver and a final. Why DAK went down that road, I don't know why. Because by this time, when these were around, the tube stuff was kind of already, I wouldn't say outdated, but definitely not really used. Everything was all solid state. But for some reason, I don't know if it was for nostalgia reasons. I honestly don't know why they would convert this Cybernet board into a tube driver and a tube final. But they did, and so it is what it is. You either love these radios or you just, don't. There's really no in between. I like them. I think the reliability issues that you find in them can kind of be tamed down a bit. Um, Probably not completely eliminated, but you got to consider the age of these things. This one still works. Well, actually, I'm still yet to test receive, but it does transmit. I'm assuming it does receive. I think it was a working unit. So, it's all these years and it's still working. So it's not that these things are, complete pieces of crap. It's just, now they need a little love. And that's basically it. But a lot of people don't want to deal with anything tube related. So they kind of get left on the wayside. So a lot of guys will actually hollow these things out and put a completely different radio in it and do it that way. I'm kind of against that. I'm for keeping the DAC original, and so wasn't the owner of this radio. So yeah, this is I'd have to say looks wise, it's definitely number one on my book. Overall, probably I'll admit I probably wouldn't buy a DAC myself. I can appreciate them. I can appreciate the look, but it's not a radio that I would willingly purchase. I guess maybe for the right price. That's always a contributing factor to whether or not you buy something. But I feel like it's not something that I would go out and pursue. I wouldn't go out and purposely look to buy a deck. If I came across one and it was a good price and whatever, I'd probably buy one. But other than that, I'm not purposely looking for a deck. But anyway, with that being said, they are wonderful looking radios. So what's going to be done to this. So it's going to get a recap alignment. You can see the meter lights are out. Well, that meter light is out. So it's going to get 4 LEDs. He wants like the cool blue LEDs in there. The SWR meter is working. The RF and the plate current meter, it doesn't seem to be working, and I don't know why. I haven't opened this radio up yet. Modulation meter is working, and the signal strength, like I said, I haven't hooked up the signal generator to this yet, so I don't know if it's working or if the meter is correct or whatnot, but we'll see how it is later on. But because I kind of have to step back a little bit here, what I'll do is I'll put you guys up on the tripod, and we'll kind of go through the features of the radio, and then we'll open it up and see what's going on. We'll actually we can do a preliminary check on the TX and RX, and see what's going on with that, and then I'll do an after video, yeah, that's about it. The other thing he wanted was, so these are wired. I have an RCA mic hooked up to this. So these are wired for a 4-pin Cybernet, which is why the RCA mic works. There is this microphone here, this D104. That is, I don't know, when I plugged it in, I had some weird sounds coming out of the radio, so I don't know what was going on with that. But he wants this wired for a 4-pin Cobra unit in the actual radio itself, so that way he can plug in, one of his various mics that he has. And I think that's a good idea, if you have if your mics are all Cobra unit in style 4-pin, I think that, changing out the pinout on the radio itself makes sense. So that's going to be done. Meter lights, basically he just wants everything working. He wants the clarifier unlocked, so I'll be doing that. And yeah, so that's about it. So let me get you guys set up on a tripod. We'll go through all these little knobs and switches and do like a quick explanation on the features. So yeah, stand by. Alright, so we'll just briefly go through some of the functions of the radio, what some of the switches do. Some of them are obvious, some of them are not. Yeah, we'll just briefly go through it. Volume is also the on and off. Obviously volume, it's the level coming out of your speaker. Squelch, basically you filter out your the signal strength of your receive. RF gain, basically just the how much power you want on your receive side. So if you want full power on your receive, do it. You can put the knob all the way. You want less power on your receive, less gain on your receive, you just turn it down. Channel selector, pretty obvious, changes the channel. Clarifier, this will adjust the frequency of your incoming receive. Obviously, if you want to lock this, it will also adjust your transmit frequency. Mode switch, AM, upper sideband, lower sideband. It's obvious. Mic gain, again, it's the, your mic power, so you can set this to full for full gain all the way down. We'll actually turn the mic off, the audio on the mic off. And you can also adjust this based on if you have a powered mic as well. So this gives you some adjustment with that. All right, AGC. AGC is it's automatic gain control. So what this circuit does is, as your receive audio is coming in, so you're getting the transmission in, you're going to find that the signal strength might fluctuate, a little bit. You might go from like 2S units to 9, or between 3 and 5, whatever. So you're not constantly adjusting the volume knob according to your RX, your receive coming in. This circuit kind of helps just mellow out the highs and the lows. And that's all that does. And why is it nice to have a switch? It's because you can kind of customize, based on your preference, how fast or how slow you want that circuit to kick in. So that's just basically it. And also, it's going to depend on whether you're on AM or one of the sidebands. You're going to find it more beneficial on sideband because, there's no carrier on AM. I'm sorry, there's no carrier on sideband, so there's a carrier on AM. So that's why it's nice to have, or even turn this off. So that's a nice feature to have. So what's transmit and standby? So this will either turn on or off the transmit, the driver, and the tube, the final tube. So basically, it kind of just gives your tubes a break, so that way they're not always on, the high voltage isn't always on. So if you're just kind of just sitting around and you're not really talking, and you're just kind of just monitoring, just kind of hearing what's going on there, you can just set that right to standby, and it turns the high voltage off on the tubes. Kind of nice to have, kind of gives your tubes a little break. And then when you set it to transmit, turns the high voltage side of the tubes on, and you're ready to transmit. So it's not like you're actually turning them completely off and on. So once you hit that transmit button, the tubes are still warm. So that's what that does. So that's a nice feature to have. A&L noise blanker. That's obviously, I don't have to really explain that. That's also, basically filters for your receive. Your RF power and your plate current. So RF power is that's kind of obvious as well, I would think. So that's basically how much power the radio is putting out. Basically, what you are when you're talking into the mic. How much wattage. When you look at the watt meter, that's basically what you're seeing here. It's just a meter for your RF power. And then this one also doubles up as plate current. So what's plate current? So because this is a hybrid radio, it does have two tubes. A plate is I'll oversimplify this again. So when you look at a vacuum tube, there's like three main parts. So you have a plate, a grid, and a cathode. There's filament, there's a bunch of stuff. But what the plate current is, so the grid controls the current inside of a vacuum tube. And the plate current is basically just a measurement of the amperage going through the tube. And that's all that is. There's no other fancy thing about that other than it's just it just measures amperage in the tube. SWR, standing wave ratio. It's obviously for your antenna. This meter does not work, so let me actually key up. That does not work. Yeah, transmit's got to be on. But yeah, still, it doesn't work. And transmit has to be on for the SWR to work. So we can actually calibrate. Yeah, transmit's on. So let's calibrate this. Key up. You go all the way to the infinity sign. More or less, right? It's right about there. Let go. Let's bring that back down to SWR. And you can see it's on a dummy load, so it's it's going to be less than 1.5, 1.2, 1.1, something like that. Yeah, modulation meter works. Audio. And then we can test the signal strength meter. We'll put an S9 signal to it and see if it actually matches that. So that's basically it for the radio and all of its functions and switches and meters and whatnot. So yeah, let me. The next step is to. Well, actually, we can just see what she's doing for power. Let me just pick you guys up here and you can kind of see. You're on a tripod, so I can't really focus in, but this is AM. So we do have a 4-watt carrier. That's good. Audio, audio, audio. All right, swinging to like 11. That's about normal. Let's go to upper sideband. So the mic gain's all the way up, RF gain's all the way up. All right, we got good carrier suppression. Audio, audio. All right, what's that, like 11? I think I can see from here, 12 about. Audio, audio. Yeah, maybe more like 14, 15. All right, lower sideband. Again, no carrier. That's good. Audio. Audio. Seems like we got a little bit more power on lower sideband. Audio. Audio. Yeah, not too much though. But again, an alignment will it's going to help with that. All right. Let me get this on a signal generator, and we'll see if that is working, and see if actually we get an S9 signal. All right, stand by. All right, so I actually do have an S9 signal going to the radio, and the meter is dead. I wonder why. You know, you get 2 dead meters here. But again, I haven't opened this up yet, so I don't know what it is. But it is receiving on AM. Go to upper sideband, even though we're off frequency, but we can check still. I wonder if something's up with the squelch. It's a little wonky. And lower sideband, she's really deaf on lower sideband. Yeah, so hopefully a recap and alignment will help with that receive. So yeah, this definitely needs some work. I mean, it's it's going to get a complete service. So yeah. All right. So yeah, we have 2 dead meters. And I don't know, the squelch is a little weird, a little wonky. So I'll probably take a look. Well, I'll take a look at everything, but that could be this could be an issue. Yeah, so that's basically it. Let me get this open, and we can take a look inside and see what's going on. It only, there's only 8,000 screws holding this thing together, so it shouldn't take me too long. All right, stand by.
48 hours later.
All right, so here we go. Cover is off, and you can kind of see the downfall of these radios is this board here. I don't know if you guys can see, but it is wavy. It is like a basically like a indent right here in the middle of the board, and it's just so basically just kind of like wavy like that. But yeah, so got a Sylvania final and then the driver tube. But yeah, it's all original, original caps. So, but yeah, I mean, it's very typical of these radios. You'll hear people call these high gain boards. I don't know if that's correct. I know high gain, used Cybernet boards. I've never known high gain for making circuit boards. But yeah, I mean, you could tell you the VCO block right here. Very common. Looks like a Cybernet board. But I don't know if Cybernet would have made such a, I don't know, low-grade board. I don't know if it's, maybe it's not even the board, maybe it's the way it's mounted. That probably, that's could be the problem. Maybe not enough support. I don't know, but all I know is, yeah, this is the main downfall to these radios is this whole board here. But the best thing to do is just leave it as is. Don't mess with anything that you don't have to mess with. Basically, just do your caps and yeah, align it. There's no reason to go looking for trouble. But yeah, so that's basically it. Do some cleaning in there. Obviously, when the unit is off. We'll also get some. The owner wanted some spare vacuum tubes, so I'll get some spares for him. That's what he wanted, so I'll get him some. But that's basically it for this radio. We kind of did the preliminary check and kind of got an idea of what's working, what's not working. I have a feeling that this meter right here, it is just seized, locked up. So we'll have to maybe try to free it up or try to source maybe a used one. I don't know yet. Same thing with this one here. Because when I tried shaking it and I don't see the needle moving at all like the others. So that one's definitely seized up. But I don't know. When I get to it, I'll know for sure once I start, digging into it. But I think that's about it for this particular radio for now. Stay tuned for a part 2. Probably won't be for a while. Because things are kind of slammed here, but yeah, probably be a couple of weeks. But anyway, yeah, stay tuned for part 2, and that's about it. Thanks for watching, guys. Well, I had a few minutes after I did my initial inspection, and I kind of went over the board a little bit closer, and I found out that somebody has already tried to repair this board several times. Let me try to get a light in here, but you can see, let me try to get a pointer. You can see somebody tried to repair a trace by putting a little I don't know, maybe the end of like a capacitor or something there on top of the board being so warped. It's just bad. And then there's such a big radio, I can't get proper lighting in here, but where is it? Well, right in there. Huge globs of solder trying to replace or repair a trace. And then all these pass-throughs are popping. Really bad. Really, really bad. So I'm not quite sure what to do. This is going to be quite an extensive repair. But yeah, all these little... That one's popped. That one there is popped. Somebody has already gone over several of these pass-throughs. see if that's any better. Yeah, you can see on that one there, the head is starting to pop off, and it's a very common thing with these. So this is going to need some extensive pass-through repairs. Look at those huge globs of solder somebody did in hopes of repairing. Right there, right there, right there, there. This is the issue with this DAK, and this is its downfall, is this board and these pass-throughs and again, I don't know if it's just poor design or I don't know, but one thing's for sure is this board's going to need extensive work to get right. And on top of that, the movement on this signal meter was stuck, and somebody had put glue in it in the hopes of trying to keep the adjustment in place, but ended up gluing the movement. I don't know why, but that's how it is. Sometimes, you know, it's an unfortunate thing. So now, you know, these parts for this tough to find or super expensive. The plate current meter, it's not stuck, but however, it's whatever circuit is supplying information to it is just, it's not working. And it could be one of those pass-throughs. It could be just a bad trace. At this point, who knows? But this is, it's a pretty extensive repair. And then look on the back side here. I mean, it is pretty bad. Pretty bad. But yeah, I'm gonna have to contact the customer and see what he wants to do, because this is going to be you know, an extensive repair. And there's a huge, I know you can't tell, but there is a huge bubble here. So that divot on the top, you can actually see in person, you can see a huge bump on this side right here. And who knows if it had popped some of these circuit traces, or it popped. I mean, I could see somebody went back over with this with a soldering iron and just kind of balled some stuff up. You know, it might fix the issue temporarily, but you have to use like a desoldering iron first, and then resolder. You know, because that's, if you don't do that and you get like these balls of like solder, you know, it might be okay temporarily, but they're just going to pop again. What you want to do is you want to remove all that bad solder, and you know, try to flow some better, some new solder. But anyway, yeah, this is the downfall of these DAKs, and you know, not that I would like to see it done, but you know, you can kind of get the idea why you know, people, you know, put completely new radios inside of these. It can be expensive, it can be troublesome, and at the same time, you know, you can, as a tech, I know you can go over every single part of this board and fix it, and then, you know, the next moment, you know, something else is broken again. You know, especially with this board. But yeah, that's where I'm at right now. But we'll see what the owner wants to do. All right, guys, thanks for watching.